Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In last time, we were talking about line integrals, and what I wanted to do today is to extend that to the case where we have a conservative or basically vector fields. We are going to talk about conservative fields later, but vector fields are fields where you have a vector and there is a particle moving and we want to see, or how to calculate the linear integral. And most of the time you will be asked to find the work done by the force. We remember that the work is basically F, the magnitude of the force, dot, or as a force as a vector, dot r, which is the displacement, right? So if we have a force acting on a particle and moving along the line of action of the force, so all what you have to do is to multiply the force by the distance traveled by the force. If the force is opposite to the motion, like the case of friction forces, that will produce negative work, right? So generally speaking, we say that the work is the integral of F dot dr, where r is the displacement. So now, because if the motion is along, a curve, but the force has a specific direction, we know that when you do a dot product, all what you are doing is you are multiplying the magnitude of the force times the magnitude of the distance times the angle, the cosine of the angle between them. So basically, you are projecting the force in the direction of the tangent to the curve at a point and multiplying those. So it's the integral. So along the whole curve, it would be the integral of f dot dr. So we can refer to it. It's a line integral, so we usually do that, and we say f dot dr. So what we are going to do today is to look at cases where I have a force in vector form and R is a curve. So all what we have to do again is to parameterize both the force and dr. And we learned that, you say dr dt, um, and f dot dr dt will, in fact, here I should say f dot r, right? But anyway, let's take an example and illustrate that easily or make it simpler. I'm sorry, I dropped the pen. So here, let's take let's take an example where my force given here is x, comma, uh, say 3xy, comma, uh, negative x plus z. I usually prefer to write these in vector form. Mathematicians usually like this form, but I would say or xi plus 3xyj minus x plus zk. And then they tell you find the work done by this force on a particle that starts at point in 3D. It starts at let's say 3, 6, 4, and it goes to 2, let's say 7 and 3. Let's do that. So before we start, we have to find r of t, right? So I'm going to parameterize that motion from 0.364 to 0.273. You learned that before, but it's really so easy. All what you have to do, in fact, you can do it in infinitely many ways, okay? But the easiest way is to say, okay, I'm going to pick my variable t, the parameter, and say, I want when t equals 0, I am here, and when t equals 1, I go there. So let's see how that works. You see how easy it is. So in the x direction, I say if t is 0, I am at 3. So really, I don't need to do anything. No t's here because t equals 0, right? But when t equals 1, I have to go to 2, meaning I have to subtract 1. So let's say subtract t, and then we say t goes from 0 to 1. You see, if t is 0, you are at 3. When t is 1, you go to 2. And that's in the I direction. And then you say, but don't I change that for the y? Yeah, absolutely. Same, but I use the same logic. If t is 0, meaning the first element doesn't have any t, I'm going to write 6. And then it will increase by 1. So exactly instead of decreasing by 1, I'm going to say plus t j. And then finally, same logic. I am at 4. Notice if that was like from 4 to 1, I would say, instead of saying minus t, I would say minus 3t. So treat the t as if it were 1, because usually what we are going to do after that is to say t goes from 0 to 1. I could have made t equals goes from 0 to 1 half or from 1 to 2, and I can mix and match. I can pick any values and readjust my work. But common sense would say 0 and 1 are the easiest. In fact, even when you integrate, you don't, most of the time, you won't have to worry about the 0, right? Because if that's a power function, or I mean, like an x, or like a polynomial, you don't have to subtract anything. When you take the integral, it's just the sum of the coefficients, right? Okay. So what we are going to do here, we want to do an integral. So the work would equal the integral from some values. It's a linear line integral. I'm going to find f in terms of r of t dot r prime of t dt. So let's find r prime of t. That's so easy, right? R prime of t would be negative I, because when you take the derivative with respect to t, you get negative 1, plus j minus k. It's as simple as that. And then when you do the force, you have to write the force of r of t using now the x is this, the y is that, and the z is that. So I have 3 minus t is the x. This is x, so it would be 3 minus ti. I'm sorry, 3xy would be 3 times x times y. And then the k is negative x plus z. We can simplify that by saying 3 minus ti, and then here you do the product. So you get negative t squared and 3. It's negative 3t squared. You have negative 6t and positive 3t. That's negative 3t times 3 is negative 9t. And then for the constant, you get 3 times 6 is 18 times 3 is 54j. Forgot the positive here. And then minus, I have 7 minus 2t. Okay. The last step before the integral, it seems like a lot of work, but really it isn't, right? Um, Now you do the f of r of t dot the r prime, or dr dt if you want, equals. Notice in the dot product, the I dot j and the I dot k and the j dot I and the j dot k, all of these are zeros. all what we do is to say I dot I is 1, j dot j is 1, k dot k is 1. So you don't have any vectors. It's just a scalar quantity. Negative 1 times times 3 minus t, it becomes t minus 3. Then 1 times that, it means I'm going to write these as they are. And then negative times negative is positive, so plus 7 minus 2k. Oh, I'm sorry, minus 2t, not 2k. Why did I say 2k? Okay, equals negative 3t squared, and then the t's I have t, minus 9 is negative 8, minus 2 is negative 10t, and then I have negative 3 plus 54 is 51, plus 7 is 58. And finally, I say the work equals the integral. Notice the t goes from 0 to 1. I made it easy on myself. Of these quantities, negative 3t squared minus 10t plus 58 dt. So it equals negative 3 times t cubed over 3. So the 3 and the 3 cancel and I get negative t cubed. T squared over 2 would make that negative 5t squared. And the 58 seems not very large, but yeah, it's multiplied by 3. It is. And the x and the y, you have 18 times 3. Okay, so plus 58t and everything evaluated from 0 to 1. That's what I was telling you. I don't really need to care about the 0. I would say 58 minus 5 minus 1 is 52. 52 work units, whatever the units are, joule or pound inch or whatever you have. And that's basically it. I hope that was easy. In the next session, I will give you more examples, different cases, different scenarios, and then we can move forward. I just didn't want to make it a long session. Thanks for your time and hope to see you soon.